Hi there, my name is Christine Hurst Bernhardt, and I'm going to be sharing my research with you today, which is still a work in progress, but it's really getting there. I titled this Contextualizing Astronomy Education with AI-Assisted Epistemic Network Analysis. Last year, I presented the preliminary findings of this same data set, but I've really gone back through and reanalyzed this with the use of AI-assisted and AI-generated coding, which I then combined with my own, which I'll explain. So, a little background. As we know, Earth and space sciences are the most historically neglected content area of any content. Myself, and Saeed Salimpour have both well documented that. But at the same time, there are a lot of opportunities for teachers to engage in space experiments, many for low and no cost, such as high altitude ballooning, designing CubeSats, use of or analyzation of space seeds that have been up to the International Space Station. So increasing opportunities for students to engage with space. And I wanted to look at what does this actually look like in classrooms? What are teachers' perceptions of these things? Because there isn't any study really looking at that. In the science education literature, it largely leaves out these teacher-directed opportunities to engage with space and with experimentation in the space environment. So theoretically, I was looking at agency theory. Originally, I was really looking to ground space experiments as opportunities for students to act with epistemic agency, identity, and voice. So my research question and what I really focused on here was how did these networks, so you can see I have three research questions. What are the differences in perception of teaching astronomy between teachers who use space experiments and those who don't? And then what I focused on for this is how do the networks between these users and non-users compare? And are AI generated themes for users and non-users different? So my methodology, I had a survey that was administered via listservs and social media groups. I've pushed that out for many months. I had 45 participants, one that took it twice, so I combined that person's answers. Of the non-users of space experiments, I only had 9, and of space experiment users, I had 36. I then used, for this study, I used an epistemic network analysis. I did this in Python in Jupyter Lab, or I'm sorry, in Jupyter Notebook. I primarily used these libraries, but this included then testing AI's capability for generating thematic groups based on recurrent words and clustering. So initially, I went through and just had AI create some networks and then build some nodes and connections based on that. I then repeated this with my own networks and my own themes. So I'm going to show you what those look like. So my sample question was so this is from the survey. So for example, I took the responses to this survey and ran this through Jupyter and looked at some of the networks that were created from just this answer. So I looked at how if at all has teaching with and through space impacted your students and you. So it was a little longer. So I asked these were two columns, so two questions. How, if at all, has it impacted students? How, if at all, has it impacted you as a teacher? So these were two separate questions. I then had these AI generated themes of curiosity, engagement, career connections, love of learning. So the users of space experiments, as we'll see, these were really integrated. All possible components were connected for students and teachers. And we can see for non-users, these were really sparse and fragmented, with the benefits really isolated. So here we can see, even if you know nothing about network analysis, you can clearly see these nodes are different. These networks are different. So on the right, we have the users of space experiments. On the left, we have the non-users. And real quick, just to clarify what that means, this would be teachers who either just do classroom activities, book-led activities, worksheets would be the non-users. The users would be teachers that actively involve their students in things related to space experiments. This could be rocketry. This could be high altitude balloons, which I myself have done. This could be designing experiments that actually go to the space station, but this is in some way students designing space related experiments or engaging with space in that way. So again, these were the AI generated nodes and codes. And the thing to remember here is that even if you don't know anything about ENA, that there are three things we look at. The proximity, so that defines the conceptual connection strength, so how close the nodes are to each other. The size of the clusters, these demonstrate the ways that respondents link ideas. And then the distance, so the conceptual or the narrative separation between these concepts. So we can see that of our users, there's a ton of different themes that emerged, and you can see the strength of these connections between them. Blue are our students, and orange are our teachers. So you can see that there is connections between student and teachers, whereas for our non-users, sorry, there is an orange one underneath this legend here. You can see there's really no connection between them at all. And the ones that are connected, it's a very weak connection, 0.09, whereas over here, these connections are significantly stronger, more frequent. So the thickness of the line also determines the strength of the connection. So then I went back through because those weren't actually codes that when I went through the data that I necessarily agreed with. Remember, this is looking based on just frequency was how AI did it, but it didn't attach any sort of qualitative meaning to that. So I went back through and coded myself, and I generated codes related to motivation, engagement, experiential evidence, and hands-on learning, and then inquiry orientation. And I'll explain those here. Um, oh, sorry. You can see that since I only came up with three, I learned this the hard way, as I am also learning network analysis. Three means you're always going to get a triangle. But even looking at these, so this time it swapped. The users are on the left, the non-users are on the right. You can see that the motivation and engagement for the users is 45, on the non-users is 9. So even though it's still a triangle, the strength of connections is more frequent and stronger in the users than the non-users. So then what I did is I decided I wanted to combine, that I wanted to combine the AI generated codes with my generated codes. And here are the coordinates that we'll see on the two-dimensional plane in a moment. But this then gave me five codes. So I had student curiosity, student career connections, teacher rejuvenation, teacher personal benefit, teacher professional network. And then I have the interpretations here. So here is a two-dimensional space. So here we can see that the teacher personal benefit is way down here, and you'll see on the networks I show you in a moment, you won't even see that because it didn't fit on the page. But we can see that a lot of the student benefits are really buried within the teacher benefit. And it's important to remember that when looking at whether it's a two-dimensional or a three-dimensional network, that top bottom is not associated at all with positive or negative. We're really looking for proximity in conceptual closeness. So we can see conceptually the things that are close together look to be like student curiosity, student deep understanding, which makes sense. And teacher professional growth is really smack in the middle, which is interesting. So that indicates that as students are more curious, deeply understanding, this is also indicative of teachers' professional growth, or a connection between those experiences that foster one, foster another. So here is, this took me probably 25 hours to finally get these codes right to come up with. So the combined network analysis of the AI generated versus my themes, the non-users is on the left, the users is on the right. Sorry, I keep swapping sides on you. And here you can see I added the quantitative value to the weight of the lines as well. So again, the student is blue, teacher is orange, and I added in a legend so you can see the weak, moderate, and strong connections. So if we take a look at our non-users, we can see that there's a strong connection between teacher professional growth and career connections. That's our strongest connection, which is interesting. But most of these others are very thin lines. Even if you can't read the numbers, they're weak connections. Whereas the lines and the connections between all of the different nodes for our users are much thicker, they're much stronger. And you can see that there's connections to every single node. So we have a lot of interconnection between each of these elements. And a lot of these kind of seem like common sense, like curiosity, motivation, as those are higher. Teachers are going to feel better about that as well. But what was interesting is this idea of teacher rejuvenation. I saw that repeatedly as I was looking through the data for teachers that use space experiments, that it was professionally rejuvenating. So those were spatially closer. The personal benefit that you can't even see it, it's really far off. But the student focused items cluster around the middle. So the epistemic network analysis indicates these key differences in perception and experience of teachers of astronomy between users and non-users of space experiments. And we can see this interconnectedness between the benefits for users, between students and teacher professional development. Whereas for non-users, this is really sparse and fragmented, and the benefits are really not part of a cohesive system. So this indicates that there are weaker ties and limited conceptual integration. So for non-users, I also saw that the perceived benefits were really indicative of isolated outcomes. There was a failure to link the instructional benefits to professional benefits. They also, in digging deeper in the data, non-users indicated greater barriers to bringing astronomy into their courses. But the greater picture here is that what this revealed is that hands-on astronomy experiences, such as space experiments, could be a powerful learning tool, which could then feed into and enhance the STEM pipeline. Additionally, my conclusion as far as AI and human coding is that coding or combining AI assisted text analysis may expand opportunities for data and for analysis and for research in general. And that combination really yielded a nuance that neither could have achieved alone. However, human eyes were required. So just as AI cannot replace teachers, AI cannot replace a researcher. That is all I have for you. Thank you very much. Here is my contact information. Feel free to reach out. Thank you.